Good morning, good afternoon. My name is Carsten Traupe. I'm Director Product Management with IDS Imaging Development Systems. And my talk today will be about From System to Sensor, which is about the recent developments in the area of vision systems. Let me first start with a core sentence of our company philosophy, which is the sentence, "It's so easy." And for us, this means simplicity means efficiency. And I hope I'm able to show you alongside these trends in vision systems I'm going to show you today how we use this sentence to develop our own solution in this very meaning. But as a start, let me give you an overview what I'm trying to talk about today. So let me start with a short definition what a vision system is. And then from this perspective, let me highlight what traditional PC-based vision systems are and what their characteristics are. I'd then like to say some words about this trend about embedded vision, and which ultimately then leads to my core topic, the vision sensor. A talk about vision systems these days would not be complete without a short detour about deep learning. And then I'd like to show you what we believe simple yet effective vision system, our IDS NXT Ocean system is. And then I'd like to conclude with a summary. So what is a vision system? Well, basically a vision system in a very simple sense is, as shown here on the diagram on the left, it takes light as input, which is in the end images from objects you would want to analyze, observe, or inspect. And within the vision system, you process these images according to algorithms which are suitable to the task. And ultimately, the output are these results of this image processing, which is machine-readable data, which is processed further in machine control systems on the shop floor, for example. Since IDS is a camera manufacturer too, it's very important to note for this talk that a vision system is not a camera. It's the complete system from image capturing to output to a subsequent system, which is receiving data, machine-readable data, as base on these images. So where did the whole thing start in our industry? It all started with traditional PC-based vision systems. And as you see here, of course, a traditional PC-based vision system has a camera, a lens, some lighting to illuminate the scene, some trigger source to signal to the camera when to capture an image. But then the images are transferred from the camera to a PC. And this is really a base PC out of standard components. And on this PC runs a specific image analysis software to process the images. And then once the results are determined, let's say the size of an object, the color of an object, it's processed further or kind of forwarded to the machine control system I was speaking about earlier. The whole thing is pretty complex, and it, by its very means, is a physically distributed setup out of individual components as shown in my diagram here, which comes with a certain strength, which is it's pretty modular, which means you buy a PC from a PC maker, you buy a software from a software vendor, a camera from a camera maker, and so on. And but ultimately, it also results in pretty long cables from the camera to the PC. I say here tens of meters. It can vary, of course, but this is basically driven by the fact that the PC, as a standard PC, comes in a industrial PC housing, is put on the side of the shop floor in a cabinet, while the camera sits on the machine where the image has to be taken. Now, of course, with the advances in processing power and integration of processing CPUs, GPUs, and so on, the term embedded vision enters the scene. And what is this? So basically what you do here, you compactify all these components, the camera, the PC, the software, everything, into one individual housing. I call this one brick size paradigm. Yeah. So compared to what it was before, PC, housing, and so on, you have a pretty compact form factor. And this is possible because these new, very power and performance efficient SoCs, the system on chip, they encompass everything which is typically distributed over several boards and so on in a PC into one individual die. And as you know from your smartphones, this technology would not be possible without this SoC technology. And embedded vision, so to say, in a certain sense, utilizes this trend to higher integration within the semiconductor range to compactify a vision system. And suddenly, your cables are centimeters only between the camera within this housing and this SoC. And this, of course, brings absolutely new possibilities with it. Yeah? And enabling to put a complete vision system within this one brick size housing. So let me talk about what this is, this one brick size housing. This is what I call a vision sensor. And I just brought with me here our own NXT vision sensor. It's the Next Rio and then in the Next Roam. The Next Roam is an IP67 sealed shielded housing, while the Next Rio Roam is a standard housing. And don't be mistaken, this is not a camera, this is a vision system. So what I showed you before, processing, image analysis, everything is done inside this one very compact housing. And we decided to keep it flexible, so we didn't integrate lens and lighting. And this is important because these are very complex scenarios where our customers really tend to want to choose. And it would be a really restriction if we want to put this into this housing too. So we kept it, so to say, separate. But everything else of a vision system is in this housing. So it captures the image on a vision sensor, it processes the image with certain algorithms, and then it's connectable directly to the machine control system. So it's really, compared to a vision system which is based on a PC, it's really cost effective and compact. And therefore the whole system is in or at line capable, which means in automation speech, the whole vision system can be mounted within the machine or at an inspection place close to the machine. There's no long cable needed to a vision PC, which has to transmit very high data rates because it has to transmit images. It just has to transmit the results, which is, let's say, the color, the size of an object, if it's damaged or not. Pretty simple. And this is, I believe, what drives me calling this a vision sensor, because this is now really what you want to see from a sensor-like device. It's like what you are used to with pressure sensors or temperature sensors. It's one housing, one device. You put it where it belongs to, plug it in with one cable, one housing, one cable, as I put it here, and it does its job. Yeah? So the complexity of vision systems into this sensor-like housing and ease of use and ease of handling. Now, as I said before, talking these days about vision systems without having at least a short detour about deep learning is not sufficient. So I just brought here a simple example to highlight the use case. It's from food inspection, and it's a real scenario. So on this conveyor belt, there are small trays, and in these small trays, typically one pair should go in, like the upper arrow indicates. But sometimes something goes wrong, and there's no pair inside, or even worse, two pairs, because that would block the machine which is processing the pairs then afterwards. And how do you detect that there are two pairs in? And of course, there's alternatives, but here, this is one of the scenarios where deep learning really plays to its strengths. Because instead of having to understand in an engineering sense the problem in an abstract way, write algorithms, you really want to train a system on what it's supposed to see, like we humans learn by being trained on certain scenes and on certain tasks. And this is very typically very suitable for varying complex geometries or organic forms. Yeah, because here it's not really a predetermined, very exact shape you're looking at. It varies from time to time, but we humans have no problem seeing that it's a peer or there's an absence of a peer and so on. There's different modes in deep learning. It's important to understand this too. There's classification, object detections, and more. And the execution of deep learning in the vision system is called inference. And instead of, as I said, writing complex algorithms, you train your neural network on training data, which is you take a lot of images, say this is a good one, this is a bad one, here's no peer, here's two peers, and then the neural network magically does its job. Yeah, it's very important to note, since a lot of people are asking these questions, that deep learning will not replace traditional rule-based algorithm. It's a completion. It enables computer vision or machine vision into areas where it wasn't possible in the past to solve certain problems with traditional algorithms. And these days, I think the times are over where people were looking at this in doubt whether this is kind of suitable or not. It's reality, it's used, and you should look for it because it will help you in certain cases tremendously to solve your tasks. I'd like to keep it at that because there will be subsequent tasks in this channel where we will be exclusively targeted at deep learning. And I just wanted to give you a first short glimpse on this technology so you understand why this is so important. Now, I'd like to come to my example, the IDS NXT Ocean, which is a complete solution centered around a vision sensor. So let me first, on the left side here, talk a little bit about what complete means. So first of all, as any vision system, you need to be able to program algorithms, software to your needs to do your vision tasks. And therefore, a complete solution around a vision sensor needs to have a custom vision app development. We call these programs app because they can be loaded and managed on the vision sensor, the NXT Ocean, the Rio and Rome vision sensor like apps. Yeah. As I said before, really state-of-the-art vision system should be deep learning enabled. Otherwise, you're missing an important part of tasks to solve. And then you remember from the beginning, you want to connect your vision sensor directly to machine control systems. It has to speak industrial protocols, which they are used to operate on, for example, OPC UA. So now talking about the NXT Ocean system, it comes with a complete tool chain of a vision system. First of all, my talk was about the vision sensor. As I said here, the Rio and Rome complete vision system in an embedded vision form factor, the vision sensor. Of course, as I said before, when you want to train neural networks, when you want to use deep learning, you need to have a training system. And of course, you need to supply this to prepare the neural networks to do the deep learning inference on the camera. Here, our system is called NXT Lighthouse. And very importantly, it's a cloud-based system, which is a tremendous advantage over standard systems you have to kind of put on a PC you own, because you have to select the hardware, you have to purchase it. These training servers are not cheap, and you have to install it, you have to do your tests, and afterwards you sit on the server hardware. And we believe it's much more efficient to do this cloud-based. So you can just log onto the system, you purchase a license on a monthly base, and use the system to train your data. And if you don't need it anymore, you stop the license. There's really minimal investments from your side to do this. Of course, it's tailor-made to the vision sensor, to the NXT Rio and Rome. And then we call it the NXT Vision App Creator as our software development environment. For in the case you want to employ traditional rule-based algorithms where you want to program by yourself. Of course, you can use third-party libraries too. A lot of algorithms are already available at, for example, the OpenCV library. A lot of you would be familiar about. So the message you should take from this slide is the vision sensor is at the heart of the solution, the vision system in the compact embedded vision form factor. But you need a complete tool chain to make this system really workable and practical. So let me summarize what I wanted to bring across today in my talk. First, today's vision systems do not require any more PCs or distributed setup. They can be put into these embedded form factors, very compact and very also cost efficient. They are powered by SoCs, which are very performance and efficiency, very performant and efficient in terms of size and power. And they enable putting together a vision system within this one brick paradigm housing. Deep learning should be available in a vision system today. As I tried to show you, this is a very important completion of what functionality you want to have at your fingertips when you use the system. And these vision sensors, like the IDS NXT Rio and Rome, they are reality today. They're not something at the horizon to look for. They can be purchased off the shelf. And they would solve a lot of vision tasks in a very simple, cost-effective, yet flexible manner. With this, I'm at the end of my talk. I'd like to say thank you for listening and open the floor to questions.